Alright, so the problem was to use the trigonometric substitution, square root of x equals sine x, or sine theta, to determine the integral of square root of x times the square root of 1 minus x dx. So we know it's a trig substitution, so the first thing I do is I draw my triangle here. And that's not what I want. And I'm going to go ahead and let this angle usually works best, equal theta. And we know the what they've given us for our substitution to use is sine theta equals square root of x. Now, an easy way to make this statement true is if sine theta, opposite of our hypotenuse, so the opposite side equals square root of x, hypotenuse equals 1. And let's go ahead and solve for our base of our triangle here, which is pretty easy with our hypotenuse being 1. That's just square root of 1 minus x. And if you don't know how that really works, Pythagorean's theorem says a squared plus b squared equals c squared. Let's say we want to solve for one of the sides, a, c squared minus b squared equals a squared, and then square root c squared minus b squared equals a. Okay, so I hope you understand that part at least. It's me undoing all that. So we have something to fill in for square root of x. So let's find a substitution for square root of 1 minus x. You can look at this and see that that's fairly easy to find. Let's look at cosine theta. And what's that? That's adjacent over hypotenuse, which will be square root of 1 minus x. Now you might be tempted to think that we have everything solved, and or at least for our integral, for our substitutions. However, this is not the case, but we'll go ahead and write it out so you can see. We have an integral, square root of x is sine theta, and then we have cosine theta for our other square root of 1 minus x. But we have this dx here. Now, the way we get rid of this dx is we take one of these substitutions and we solve for dx. And I'll show you how we do that. Let's take sine theta equals square root x. Let's solve for x first. Square both sides. Sine squared theta equals x. Take the derivative of both sides. We have a little chain rule going on here. 2 sine theta cosine theta equals dx. Bam. We solve for our dx. Alright, so let's go ahead and fill everything in. We have integral sine theta cosine theta. There should be a d theta here. Then our dx is 2 sine theta cosine theta d theta. What just happened? Alright. So let's go ahead and start grouping things together. Let's pull our 2 out. Integral sine squared theta cosine squared theta d theta. And as you can probably see, and this problem is going to be very long, the way I did it is I subbed, or I put everything in terms of cosine. So we have 2 parentheses 1 minus cosine squared theta times cosine squared theta. And I'm not going to write d theta a million times, but you know it's there. To distribute the cosine squared theta minus cosine to the 4th theta. And let's keep going with this. And then we have a, let's go ahead and break our integrals up. And while I break this up, Let's go ahead and sub a trig identity in for cosine squared theta, which is 1 plus cosine 2 theta. This makes this a little bit easier to solve. Over 2 minus 2 times the integral. Actually, let's do a trig identity here also. And I'll show you what we do. Let's do the same identity, 1 plus cosine 2 theta squared over 4, which is just 2 squared, obviously. Now we want to keep going with this. Let's pull our 1/2 out. We get, well, that'll just go to 1. So now we get the integral 1 plus the integral. I broke my integral up. I always do that. It makes it easier for me. Cosine 2 theta minus, we bring our 4 out, we get 1 over 2 integral, parentheses 1 plus cosine 2 theta and squared. Okay. Let's solve for these two. Remember there's supposed to be d thetas there, but I'm lazy. So we have a theta plus, let's do a u substitution. du equals 2d theta. And we bring our 1/2 out. We get plus 1/2. Integral of cosine is sine. And minus, yeah, I know there's plus c's to all these, but the c's will all group together at the end. Minus 1/2, and remember this is a, let me put this up. This is this term here squared, so let's go minus 1/2 integral, and let's go ahead and FOIL this out. Cosine squared 2 theta plus 2 cosine 2 theta plus 1. Okay. And let's, we already have these two terms on the left. Let's just draw a little arrow saying we're going to come back to these. All right, let's not forget about those. Hopefully I won't forget about them. And let's solve all this junk over here. So let's go ahead and break our integrals up. We have a minus 1/2 cosine squared 2 theta minus 1/2 2 cosine 2 theta, and we're going to scroll over a little bit more again. Minus 1/2 integral 1, and I'll go d theta. Alright, so we'll have to do another trig identity here. Minus 1/2 integral 1 plus cosine 2 times the u inside of the cosine, so it's going to be 4 theta over 2 minus, let's bring our 2 out. We get the, actually let's solve this one. Let u equal to theta, du equal to d theta. That's a theta, sloppy one. And we bring our 1/2 out. Actually, we already have our 2d theta in there, so that this 2 just gets absorbed, our 1/2 stays, and we get minus 1/2 integral of cosine sine sine 2 theta, and minus 1/2 theta. Alright, let's keep going. So we bring our 1/2 here, we get a 1/4. I brought that 1/2 out. Let's break our integral up. 1, that's not a plus, minus 1/4 cosine 4 theta minus 1/2. That integral shouldn't be there. Sine 2 theta minus 1/2 theta. And let me fix that real quick. Oh god. Yeah, close all. Take this. Actually, let's just do this right here. Bring it black. Bam. And go back to our brush. Okay, so we have those two functions there. Or I'm sorry, these two terms here are already solved for. We can already solve for that. That's -1/4 theta. We could solve for this now. Let u equal 4 theta. Did I do that right? I feel like I missed something there. Alright, u equals 4 theta. Du equals 4d theta. And we bring our 4 out. Cosine squared 2 theta. 1 plus cosine 4 theta over 2. Cosine 2 theta. We'll see where this goes. Cosine 4 theta. And we get our fourth out, we get -1/16. Get rid of this. U equals 4 theta. Du equals 4d theta. Now we bring our 1/4 out. We get 1/16. Or integral of cosine is sine. Sine 4 theta minus 1/2 sine 2 theta minus 1/2 theta. Alright, what did we have to bring down? Theta plus 1/2 sine 2 theta. So we have a theta plus 1/2 sine 2 theta. So we're going to have to definitely zoom out now to look at all this. Alright, so we have all our integrals solved. Now we got to look back up here at our substitutions, and let's see if I can copy this. Alright, so we're looking back here at our substitutions. We got to get everything back in terms of the original parameters, which is x. So the first thing we need to do, and we can see it right here, is we have a theta in the term. Actually, let's go ahead and simplify this first. So we have a theta, negative 1/4 theta, and a minus 1/2 theta. So what does that equal? -4, that's 2/4 minus 3/4, so we're left with 1/4. I don't want to select thing. We're left with 1/4 theta. So we got rid of these. Now what do we have? We have a negative 1/2 sine 2 theta and a positive 1/2 sine theta. So that goes to 0. And we have a minus 1/16 sine 4 theta. Okay. Oh wait, sorry. Let me just put this out here so you guys know. So you guys recognize. Alright, so we have a 1/4 theta minus 1/16 sine 4 theta. To get these in terms of x, let's solve for this. We know sine theta. Actually, we know sine 4 theta is not in our parameters, and there's no way really we're going to be able to solve for that. Besides having to do some more tedious trig identities. So we have minus 1/16. Let's see. What is a trig identity we can use? Sine 2 theta equals 2 sine theta cosine theta. So we can get 2 sine 2 theta cosine 2 theta. That's why this is why you don't send me workshop problems, right? And we can go ahead and break that down again. So let's pull our 2 out. Now that gives us -1/8. And we're going to take our sine 2 theta, and we're just going to do the same thing. Is 2 sine theta cosine theta, but our cosine 2 theta doesn't break down that easy. Let's use 2 cosine squared theta minus 1. Sine squared theta minus 1. We have our plus theta down here, whatever. And we have our 1/4 theta right here. Now let's continue the path here. Actually, we know what all these things equal. We just need to figure out what theta equals. So let's go back over here. We know sine theta equals square root x. Then theta equals sine inverse or arc sine. Oops, arc sine square root x. So we're left with 1/4 arc sine square root x minus, let's bring our 2 out, minus 1/4 sine theta cosine theta, and we have still our 2 cosine squared theta minus 1 plus c. And let's go ahead and do our trig identities from here, or our substitutions from here. No, I'll go ahead and distribute that. Screw it, I've already spent 30 minutes on this thing. Alright, so 1/4 arc sine root x minus, let's go 1/4, we'll distribute that later. Sine theta cosine cubed theta times 2 minus sine theta cosine theta. Plus c. Alright. Oh, well, I already did my substitution for theta. Well, let's look what sine is. Let's just move this, copy and paste this thing. So sine theta is square root of x, cosine theta is square root of 1 minus x. So we go, oh my gosh, 1/4 arc sine square root x minus 1/4 sine theta, which is root x, cosine cubed theta, which is 1 minus x cubed, all this is times 2, minus root x, I saw that sine theta in the corner, times root 1 minus x plus c. It never ends. And actually, I think that is it. So 0 to 1. Alright, so what I did is I paused the video for a couple seconds and checked my problem as best as I could. I evaluated the original integral, and I'll zoom out to show you. Alright, so the original integral was integral square root of x times the square root of 1 minus x dx. And I took it to Mathematica, square root of x times square root of 1 minus x, and I just chose some arbitrary numbers here that worked in the integral as x goes from 0 to 1. So I made it a definite integral, and I got pi over 8. So if we look at our equations down here, and we evaluated this integral on pi over 8, and what did that see there? We're evaluating this integral from 0 to 1. We see if we plug 1 in, arc sine of 1 is pi over 2, which gives us pi over 8 here. A 1 here is going to zero this whole thing out. A 1 here is going to zero this whole thing out. And if we do 0 minus the f of b, we have 0, 0, and 0. So in fact we do get pi over 8.